Okay, hello and welcome to the next video where I'll be talking about Python and we'll give you an intro to Python. First, we'll talk a bit theoretically before moving to a more practical hands-on of using Python. So let's dive right in. First, why Python? So over the last few years, Python has strongly gained popularity, steadily rising. You can see this in this graph that shows the popularity of different programming languages over time over the last few years. And please mind that this is using a logarithmic scale. So even though everything is quite close together, the differences between popularity values are actually quite big. So you can see here on the left, it ranging from 1 to 5 to 10%, and like for the different lines. And then on the right here, we can see that in 2018, Python overtook Java as the most popular language, and now being at a roughly steady 30% in, I think the metric that they use here for this popularity index is roughly based on people searching for tutorials. So you can actually also see that Python is much more popular compared to R, which sits at roughly 5% of users, although actually also R is steadily gaining users. And you can see this even more clearly if you look at the table directly. So this is just using the most latest data, that we can clearly see Python at the top of the list, a few languages in between, but also actually R being quite popular, also due to the recent increase in just data science. Again, this might not be the definite like programming language popularity index, but like it just gives you an idea of how these languages are, or how popular it is. So then, and next up, like I think this is a very classic question, R versus Python. Also, I'll briefly talk about why we're actually teaching R in this course and not Python primarily. But actually, I think, and quite often in data science, this question comes like, are you using R or Python? I actually think in practice, it's much more useful to know both of these and to use them in conjunction. So I would actually suggest to typically have an R and Python. So let's look at this. I think in my mind, both questions have some different strengths and weaknesses. They actually really go well just hand in hand. So if you look at R here, I think the benefits are that it's really quite flexible. It is really, really useful for just data wrangling. So if you're quickly working with data, the tidyverse is, in my opinion, still really the most ergonomic way of doing this, the quickest way of just wrangling around data, transforming it. It is not as popular as Python, so that's actually one of the weaknesses. I do believe it's much more suitable for statistics, and also it has many more packages and libraries to do statistics with. So quite often when you want to do something more specific, so for example, Bayesian statistics or something, you will find that either R has like more libraries, or just like some things are just only supported in R, which is more present in the statistics community. So sometimes if you want to do certain tests, you will have to use R. There may not be a Python equivalent. And while R does not necessarily have the best package management, like sometimes you really have some very annoying issues with R and packages, especially in the long run, there is really the packages that are there and that are on cron are like of really high quality, and they're really being reviewed, which is something very unique, because people just do this like voluntarily. And also what's actually quite nice about R is that it has quite a lot of built-in features already, right? You know that, like, for example, for correlations, we didn't need to install anything to just run basic correlations. There might be more ergonomic packages like the easy stats, but it has built-in support, and especially also for vectors. So for doing quite a lot of like data science related math and these things, it all comes within R, which is really nice. And if we contrast this to Python, one of the biggest benefits of Python is just its high popularity. This means it has many packages available, especially in the data science, machine learning, and AI world. It became the de facto standard for many things. So I mean, PyTorch and all these like deep learning libraries, it's all Python first, really. And it's compared to R, it's much more suitable for like proper programming. So if you want to develop like more complex applications, it aligns much more with like also other programming language in a way. So if you know Python, it translates much better to, for example, JavaScript or Java. as opposed to R, which does like very many things in like its own way, which sometimes isn't the greatest. But then R just has this insane flexibility, which allows you to do many things. And one of the downsides of Python is that like it has quite a fragmented ecosystem with many different Python versions floating around. And I just out of my experience over the last couple of years, really noticed that like Python just in terms of versioning gives you a bit more trouble than R. Some of R versions seem to be like more stable between each other and like less changes, which means that if you upgrade a Python version, you have to like more dependencies to hand it out if you still want to run an old project, which can really be like quite a pain. So if you want to use Python, you will first need to install it. And there are many, many different ways of doing this. We suggest here to use a program called Miniconda, which is part of Anaconda, which is like this big environment manager. And yeah, Miniconda is like a bit more of a lightweight version because Anaconda is like really this beast of like basically managing everything and just taking up a lot of space on your computer. Miniconda is like a bit more straightforward, but still gives you a bit of this management of like different Python versions and stuff. And we linked a tutorial here that we will also put links in, I think below the video, so that you can click it and follow through to install Python via Miniconda. But you can also use a different way. It's just, this is our recommended way. Next up, if you want to run Python, this is being installed either as Python or Python 3. We will be exclusively using Python version 3 point something here. Which there also were like older Python versions, of course, available, but they're not really supported anymore. So anything is Python 3 point something now. And this is going to be installed in your computer either by Python or Python 3 to be used within your terminal. So typically you execute Python or Python programs via the terminal. You can also do this with R. It's just like a bit more uncommon to do it this way. And if you just run this by itself, it will open an interactive shell that you can then basically run Python code in. And this will also be executed, for example, if you do this via RStudio, which we'll be covering in the next video. But to get this to this terminal, you can see there's this cropped screenshot from the RStudio interface, but the terminal here lies next to this console, which we typically use for R code. So the console is just for R. And it can also run Python, but like via R basically. But as you see here, like next to it is like this basic computer terminal where you can run these command line programs like Python, for example. And then if you're in the shell, you have this, and this is basically the same as the R console, where you can just type in code. It just doesn't integrate as well into RStudio. So don't get too confused between the difference here. It's just we wanted to highlight this once. So first, let's look a bit into some of the similarities and differences between the two programs. So first, some basic things about packages and libraries in Python. So one of the differences is that Python does not come with data science capabilities out of the box, unlike R. So rather, these are handled by packages or libraries. And this is stuff that's typically already built into R. So for example, to have vector support, typically this is done by NumPy, and then data frames and data wrangling is done by the pandas package, which is also why I put the emoji up there. And yeah, there's also more modern alternatives, but this is what we'll be using here, just out of simplicity and because like a lot of the literature out there is using this. A more modern alternative for this would be polars. So like, yeah, sticking with the bare things, but again, it's just a bit of extra complexity when installing, so like we'll just keep it simple here. And one of the first differences here is that like if you install a package in Python, you do this not via the console, so you don't run Python code to install a package as you do in R, but rather you actually call it in the terminal. So you run the Python program, but then you just call this pip module, which you see here. So that's what this python-m pip stands for. Install and then the package name. And this corresponds to the R code of install.packages and then the package name. So how do you import these? So here I have first the equivalent of like R code. So you can import R code functions via here by using the namespace version of ggplot : ggplot. This is using the ggplot function in the ggplot2 package, or you can just import the whole package and then just use the function without any prefix. This is contrasted to the version in Python here. So in Python, we always need to import packages first of it. And we can either just import a single function like this. So this is importing the data frame function from the pandas package, which you can then call by itself. Or you can import the whole package, but then you need to retain the name. So here, for example, and this is a classic thing to be done in Python, is that you use an import s to not have to write the full name. If you just write import pandas, you can just use pandas.something. But this way you give pandas the name PD, and then via pd.dataframe you can call the data frame function. Yeah, so this is importing the whole package, but there's no alternate, like there's no corresponding way of just having the whole package's functions really loaded into the Python namespace. So this is important to keep in mind, that imports are slightly different between the two. And then next up, we have just a bit of example code on using data frames. So here's an example of R code. And you might also see already like some of the markup here is the same as R Markdown. So this is actually coming from a Quarto document, because Quarto has slightly better out-of-the-box Python and R support. So to use both languages at once. If we want to do the same thing in Python, this is how the code looks. So this is already taking into account the import I did before. And we use the classic pd.dataframe here. Then we give it, we have a bit more markup here, as you may see. So we give it this is called the dictionary with A for the column, and then the values in a list. These are these brackets. So you see there's more different brackets being used here. And this is actually a classic thing about Python. So different brackets have different meanings here, which we'll be talking about a bit later. But then you see, using this syntax, I created a simple data frame in the end. Okay, so what you may also be wanting to look at into when using Python going forward is that maybe you want to combine R and Python. Because of course you're already, probably most of you, much more familiar with R than Python. But as it turns out, you can actually also run Python code from within R. And sometimes this may give you a bit of trouble, but actually it does work surprisingly well. And this is done via the R package reticulate, which you can see the logo of here on the right. It's like this cute snake and the R logo. And this is also used by Quarto. So if you create a Quarto document, and instead of having R in the chunk thingy, you use Python, it will automatically use Python as the language. And if you have both in the same document, it will start using Python via reticulate. If you just have Python, it will actually just use Python directly. So it really depends on what else you have in your document here. And it can be a bit tricky to get running, or sometimes leads to errors, because there's this extra level of abstraction in between, right? You have one programming language calling the other. So if there's anything weird going on, things break down a bit. So just as a disclaimer, but still it actually works surprisingly well. And I've used this for certain notebooks to just have, for example, use Python for machine learning and then use R to wrangle the data, just because, each of these is excelling in this particular task. So if this sparked your interest, I can also recommend some further reading, because in this course, especially regarding Python, we're only really scratching the surface, because we're just having this one session dedicated to it. But you can read an introduction to Python for R users. It's a short blog post, which also will be basing on things here a bit. Which is really nice, because it has this focus of people who already know R. Just kind of translates always like this, okay, this is R code, this is Python code. So you can relate them to each other, which is really nice. If you want to have a more thorough information on it, there's also this whole book, which is called Python for Data Analysis. And I mean, this is a full-on book of information. So much more thorough, but of course also much more to read. But this really goes into detail on how to use Python for data analysis. So that's it for this video. And in the next video, we'll actually look into things in practice and run some Python code in RStudio. So see you in there.